Hello everybody. We have seen extensively the various types of sensors that are used in ADAS. Now we will see the various types of actuators that are used in ADAS. Actuators are very important. They are the actual action doers. After sensing, processing, these actuators are the one who actually instigate the action in the vehicle. Okay, so let's see briefly what are the various actuators that are used and what are their applications in ADAS, what are their importance in the scenario or in the context of ADAS. Advanced driver assistance systems rely on various actuators to execute physical actions based on sensor inputs and control algorithms. Okay, so based on the sensor input, control algorithms, based on the pre-processing, based on the post-processing, based on the software, these actuators are actual physical action executioner. Okay, these actuators play a crucial role in enhancing physical vehicle safety, comfort and also autonomy. Now let's see the various types of actuators that are used in ADAS functionalities. The most important actuator is electric power steering, because steering plays an important role in many ADAS functionalities, right from lane keeping assist to automatic emergency steering to park assist. This electric power steering actuator plays a very pivotal role. So what does it do actually? Electric power steering actuator adjusts the steering torque or angle for lane keeping, lane centering, automated parking. Okay, for when it comes to lane keeping assist, it applies the corrective torque to keep the vehicle within the lane. This sentence is very important. It is which is actually keeping the vehicle in the lane. It is the electric power steering, and it also plays a pivotal role, important role in automatic emergency steering. It steers the vehicle to avoid collisions. You understand the importance of this actuator, because when it comes to steering, it can be ASIL D functionality. It can be an ASIL D criticality. So failure of this can lead to fatality. That's the reason electric power steering is a very important actuator when it comes to ADAS. The next important important functionality is park assist. Automatically steers during parking maneuvers. Now this particular use case is not exactly very fatal, because parking usually people do in a very slow manner. So usually if at all any accident, it can only scratch the car or it can only slightly damage the bumper, but it does not exactly uh, how to say, cause a fatality or cause severe damage to the vehicle or to the passenger. So this use case is slightly ASIL B or ASIL A. Alright. Now next comes the types. What are the types of electric power steering? First is column assisted power steering, where the motor is placed in the steering column. Rack assisted power steering, where motor directly assists the steering rack. And dual pinion electric power steering, which uses two pinion gears for better control. I request all of you to learn about these mechanisms in elaborate manner by searching through internet. There are some very good videos in the YouTube where you can clearly see the distinction between these three, the difference between column, rack assisted and dual pinion EPS. But for now you understand that electric power steering is a very important actuator which plays a very pivotal role in many ADAS functionalities. Next comes the electronic brake system. Now just like steering, even electronic brake system is an actuator which is of pivotal and paramount importance. The function is to modulate the braking force for collision avoidance and stability control. Okay, because collision avoidance and stability control are very fatality critical components. Again, this actuator is of ASIL D importance. Alright, now what are the various ADAS application in autonomous emergency braking? It is very important. Adaptive cruise control, where it adjusts the distance to maintain a safe distance by decelerating and braking the vehicle. So in adaptive cruise control also it is very important. And electronic stability, it applies the selective braking to prevent the skidding. Now what are the types of electronic brakes? First is electro-hydraulic brake, which is manufactured by Bosch. This is very in demand or very popular electro-hydraulic brake. And electromechanical brake fully electronic brake wire system, example Continental's MKC1. Now this is a very state of art braking actuator which is making drastic foray into the market, which is making drastic entry into the market. This is a very state of art technology. Now next important actuator is throttle acceleration actuator. Again, depending upon the velocity required for the vehicle, acceleration plays a very important role. Okay, now its function is self obvious. It controls the engine power for speed regulation. Understand this very carefully. It controls the engine power for speed regulation. I am sure everybody knows the formula for power. P is equal to 2 pi nt by 60 divided by 1000. That gives the kilowatt. Okay, so within the formula, the N stands for the RPM. So naturally, when you control the power, the RPM also is controlled. So naturally, it comes as a very important actuator as far as adaptive cruise control is concerned. It adjusts the throttle to maintain set speed. Also in traffic jam assist, where in urban traffic, where stop and go functionality occurs very frequently, it recurs very frequently. So frequently braking and accelerating is of paramount importance. So under those circumstances, this throttle actuation actuator plays a very important role. Next is active suspension actuators. Now this may come to you as a slight surprise, because from where does this suspension come into picture when it comes to ADAS? You may think that, but I will explain you in which functionality this comes into picture. It adjusts the damping or ride height for stability and comfort. Okay, in ADAS applications, roll stability control prevents rollovers by stiffening the suspension, and it also predictive suspension adjusts the damping based on the road conditions. Okay, and also in functionalities like anti-lock braking system, in functionalities like automatic emergency braking, these active suspension actuators play a very important role. Suppose there is a sudden deceleration, suddenly the vehicle comes to an abrupt halt. This active suspension actuators ensures that the discomfort faced by the passengers in the car is minimal. Okay, if the active suspension is not good, then severe oscillation in the vehicle can happen, which can lead to severe oscillation or severe wavering to the passengers, causing severe discomfort. So active suspension actuators come into picture when automatic emergency braking happens. And what are the various types of automotive active suspension actuators? One is electromagnetic damper, and next is hydraulic pneumatic actuator. Whether with the help of electromagnetic damping or with the help of liquid based or air based suspension in luxury vehicles. Both the dampers are equally efficient depending upon the budget or depending upon the the luxury level of the vehicle, the premium level of the vehicle, the dampers are selected. Next comes the transmission actuators. When it comes to transmission actuators, this shifts the gears automatically for optimum performance. Okay, let me give you an example. When it comes to adaptive cruise control, if the vehicle suddenly slows down, then the vehicle computer automatically shifts the gear to lower gear so that higher torque is produced. So suddenly when the vehicle becomes slow, then you automatically shift to first gear if you are in a manual. So the same thing is done by the computer with the help of these transmission actuators. When it comes to ADAS applications, predictive shift control, it uses navigation data to pre-select gears. Depending upon the velocity at which you are navigating the vehicle, the pre-selected gears are selected. And also hill descent control manages gear shifts for controlled downhill driving. Okay, so these two ADAS applications along with adaptive cruise control, even automatic emergency braking also, suddenly if the vehicle comes to a standstill and you have to again stop and go, then you have to shift to the lower gear. Directly from fifth gear to the first gear, your vehicle must come into. Your vehicle must switch gears. Okay, so these switching gears, in this switching gears mechanism, transmission actuators are of extreme importance. And what are the various types? One is solenoid based actuator, another is electromechanical actuator. Solenoid based actuator is used in traditional automatic transmission, and electromagnetic actuator, which are slightly modern, slightly expensive, they are used in dual clutch transmission. Now also there is something called active aerodynamic actuators. Now these active aerodynamic actuators, they you won't see them in normal cars. You see only in some high-end sports cars where vehicle is pushed to 300 km per hour, 400 km per hour. For example, in Germany, where people regularly, for sake of enjoyment, they take the vehicle onto the autobahn and drive at 300 kmph or 400 kmph. Under those circumstances, this active aerodynamic comes into picture. Otherwise, for normal ADAS functions, this may not exactly be of much relevance. So, but anyway, let's study about it. At high speed stability, it deploys the rear spoilers. For example, in Porsche active dynamics. Now, this is what I am talking about. These are the aerodynamic actuators. Now, these kind of flaps you would have seen in some high-end sports cars like Porsche or Ferrari or even Bugatti Veyron or or Aston Martin. All these kind of high-end sports cars, you would have seen these things. Okay, now let's go to the next, but I am not spending much time into this because, as I said, for ADAS in normal passenger car vehicles, this is not of much relevance. Let's see this haptic feedback actuators. These are very important. Okay, in the ADAS functionalities, I touched upon many applications where haptic feedback is very important, whether vibrating the steering wheel or vibrating the seat or rapidly jerking and releasing the brake. All these things fall under the feedback actuators. An ADAS application, lane departure warning, vibrates the steering wheel or seat. Collision alert, trigger seat vibrations or pedal feedback. Alright, and what are these haptic feedback actuators? With the help of which actuators is this haptic feedback mechanism achieved? First is eccentric rotating mass, ERM motors, or linear resonant actuators. Both are being manufactured by big companies like Bosch, Continental, Aptiv, even Magna. All these kind of companies, they manufacture this kind of haptic feedback actuators. Of late, there are some small companies also which are playing a very important role, but these established companies are already having an established share in the market. Next comes the headlight actuator. Now, in modern vehicles, for example, in the recent times, some vehicles like Skoda Kushaq, Skoda's Enyaq, Hyundai Ioniq, they are introducing vehicles with adjustable headlight pattern or adjustable headlight angle or beam pattern. So, depending upon the actual scenario, the actual use case, curve adapting lighting, it swivels the headlights based on the steering input. Based on the steering input, it swivels or it maneuvers the headlight so that the headlight or the headlight beam is directed in the correct direction, so that the vehicle driver can have the best convenience. Next comes active grill shutter actuators. Okay, this function is open and closes the cooling vents to optimize the aerodynamics. ADAS role, it improves fuel efficiency and thermal management, especially when the vehicle is going at higher velocity. This comes into play. But again, let me point out, this is not exactly relevant for normal ADAS vehicles, passenger cars, normal sedans or SUVs which you see on the road. This is not of much relevance. This is only of relevance when it comes to vehicles which are operated at very high RPMs. So I won't say don't pay importance to it, but this is not exactly much important. Okay, so next comes the automated parking actuators. When it comes to automating parking actuators, this controls the steering. This is of extreme importance because many parking assistants, when it comes to parking assistance, controlling the steering is the most difficult thing for the driver. So there are some parking assistant systems where the computer or the vehicle totally takes control of the steering, and you have to take control only of the braking and throttle. But there are some high level vehicles where even braking and throttling are taken care by the vehicle itself. But the most important is steering, and this steering is controlled both by electromechanical or park by wire braking systems. This park by wire braking systems is a very state of art technology which is used in some high end luxury cars. Alright, so these are the major types of actuators that are being used. And now let's see one more type of actuators for your general purpose reading. So when it comes to actuators, you can divide them into hydraulic actuators, pneumatic actuators, solenoids, and piezoelectric actuators. Okay, when it comes to hydraulic, it is only with the help of the liquid force, and when it comes to pneumatic, it is because of the compressed air force, and when it comes to solenoid, it is because of the linear and the rotary motion of the solenoid. Okay, especially solenoids are used to control gear shifts in automatic transmissions. Especially in automatic transmission, the solenoids are extensively used. And next is piezoelectric, where it is used for extreme high speed and accurate fuel delivery. For example, again I will go back to the example of automatic emergency braking. Suddenly the vehicle is braked, and brake is applied onto the vehicle, then immediately at the low RPM, whatever the fuel is required, that precise amount of fuel must be injected into the combustion chamber. Okay, for such purpose piezoelectric actuators are used. Alright, even for fine tuning components like sensors and mirrors, as I mentioned here, piezoelectric actuators are used. Alright, now let's briefly touch upon some of the basic technologies which are enabling the actuators. First is by-wire, next is brushless motors, next is solenoids and piezoelectric actuators, next is hydraulic pump actuators. All these are the basic types, 4 types of actuators which are being used. Now you take any type of any actuator, by most probably they fall under these 4 categories. Alright, now what are the various challenges that these actuators are facing? First is the latency. Fast response time is critical for emergency interventions. So the requirement of the actuator should be, it should be able to respond as fast as possible, sometimes even more faster than what a human being can even think. So that's the reason why it should have as much less latency as possible. Next is the redundancy. Fail-safe mechanisms are needed for safety critical systems. So suppose one actuator fails, there should be some fail-safe mechanism to fall back. Next comes the integration. Integration between the multiple actuators. For example, integration between steering and braking, or braking or throttling, or steering and throttling, steering and haptic. All this integration is of biggest challenge. Of course, OEMs are able to meet those challenge, but still they are posing enough of financial and economical challenge. What are the future trends? Now these are the future trends that are not yet into the market, but extensive research is happening on this particular future trends. One is integrated brake steer throttle mechanism, where they want to integrate both, all the 3, brake, steering and throttle into a single entity. Next is smart materials, shape memory alloys for lightweight actuators. Next is centralized motion control. This is actually used in Tesla unified motion control. These are all the various future trends. And to conclude, let me point out, by using these actuators, ADAS systems can dynamically and transiently interact with the vehicle's physical systems to enhance safety, driving comfort, and the safety of the passenger. Okay, and also the good driving experience also. And this evolution of the architectures is closely tied to advancement in the autonomous driving technology. Okay, let me end this particular by telling one very important actuator which came into picture at the beginning of the 20th century. That is starter motor by Bosch. Okay, when starter motor came into automotive market way back in 1920s, it was a game changer. Before that, everybody used to crank the engine manually with the help of a hand. They had to start the engine with a hand. After starter motor came into a picture, you can always press the throttle or press the crank the with the key, crank the engine with the key, and the engine used to start. So that is one of the actuators which spearheaded in the automotive market. All right. So I hope all of you got a clear idea what are the various actuators used in ADAS. Thank you.